How's it going, guys? Got a little project here. Uncle is a truck driver, and he has a truck driver buddy that had this power inverter, and I guess water got spilt in it, and we'll see what's going on with it. Doesn't right now you power it up, it doesn't do anything at all. Open it up and see what burned up, and see if we can fix it. Well, you can see here, now I got them plastic ends off. It's definitely looking like the Harbor Freight type inverter. The plastic cover is screwed into the sides right here. But I'm pretty fond of the whoever the third party is that makes these inverters, OSP Tire Claw, the Harbor Freight inverter, and these here. The build quality inside is kind of generic looking and not very neat. But they always do the job that they're supposed to do. They run stacks of CFL bulbs, and some inverters are kind of fidgety about running inductive loads and stacks of inductive loads. But well, let's get this guy opened up. Alright, just like the Harbor Freight and the OSP Tire Claw, these inverters, one thing about them is kind of difficult, is like this is all the further I can get it open because the wires are getting pulled. Because the output board is mounted to the top case, while the input board is mounted to the bottom. So it kind of makes it hard to deal with. Almost got to dismount the output board just to get it open, so you can get in here and kind of see what's going on. One thing I can see different from the Harbor Freight and the OSP Tire Claw that I have, which it might be just I never owned the Harbor Freight model of this one, but the input MOSFETs are mounted to little heat sinks directly in line with the fan, rather than being on heat sinks lengthways right here. So that is different. I've seen this kind of design on a Walmart inverter. Can't think of the name of it now. I've seen this kind of design on theirs. But we'll get this output board off and get a voltmeter out and see what's going on. The most common problem with these things is when they quit working is usually is the output board. And there's rows of MOSFETs on each side, and basically it's kind of a switching device. This side switches off, this side switches on and off, on and off, on and off, back and forth, creating a somewhat of a sine wave. Typically one or maybe a couple of them on either side will burn out, and then whenever it burns out, when you go to test across these leads to see if they're shorted, oftentimes the whole bank looks shorted because one is shorted out, because they're all working together for the same cause. This side here, there is no shorts. This side here is measuring a short all the way across. I can't remember if it was these two or these two seem more shorted than the other two. Appears that these 4 fuses are burned out, while these ones over here are good. Which is kind of odd, because you think it would still try to draw current in a way, because these are kind of like separate. These work separately and then end up running together. The output power of them ends up running together for a common cause, but one can run without the other. I guess we'll take these boots off of here, these little heatsink boots, see if we can see which one is possibly the culprit due to physical, what it looks like it's damaged from the outside maybe. I'd also like to make a note that another thing that could go bad, most common on these things, is the input FETs. They could be bad too, but I hardly ever see them. I think maybe one inverter ever I've seen the input FETs burned out. Mostly it's the output. I found these are the 2 good ones, and here is the 2 bad ones. Pretty much one of them, the writing on it looked melted, or not melted, but like discolored. Was a good guess on this one. This one here, I kind of broke this one free, thinking this one was bad. I mean, you just can't tell because when you check the voltmeter. It appears that these were a pair, and obviously these and these are a pair together. But then I broke this one free, and then this one here is reading good. I can solder this one up and kind of patch it up. But we also got, here is the bad fuses. So I'm going to solder this up and replace these fuses, and this thing should power up. Even though these FETs are not there, there's no short there now, and since there is one of the bank, basically these two guys and these two guys work together. It should be able to power up momentarily and run a light load, assuming that there's nothing wrong with the input stuff. I think I'm gonna wing it. And not check these. It's just more disassembly, and I don't think that that's going to be it. We found the problem here. So we'll get this soldered up, and I got 30 amp fuses ready to go. They're not in here, they're out of the car, but I'll go out and get them. Alright, so I replaced those fuses and soldered up back up that FET. If I bought new ones, this would be just for testing purposes. If I bought a pack of new ones, probably get a pack. I mean, you just replace all of them. I wouldn't mess with these. There's a problem though. Now since I got the fuses in there, the board, checking for short on the input of it. I can't get both of them in there. There is an 18 ohm short. So that's not good. So I got to get my light out. I don't know if you guys can see it, but the first FET on this bank has a crack in it. So the input is also shorted and burned out. The only problem with this is now is that, you know, you can see that they're fastened to the heatsink with screws. How are you supposed to get those screws out? It's almost like they fastened the FETs to the heatsink and then set the whole heatsink and FETs into the board and then soldered them up. So I don't know if you guys can see that crack or not. The light. Anyways, I'm gonna see if I can get that FET disconnected from the board, see if we still have a short, and we can at least see if it powers up after that. So this project's really starting to look like a bust. The cost of the components is getting to the point to where it's going to exceed the value of the unit, or to even just to replace it. If we're just looking at these guys here, no problem, you know. I can get on there. Most of the time they want to sell you like a pack of 10, you know, and this right here is a pretty much common FET for something like this. This is actually a massive output board for this inverter. This isn't labeled right either. If this was a Harbor Freight inverter, it would say 1000 watt, not 2000 watt. This only has 2 transformers in it, and probably each one of these is capable at its most about 500 watts each. This is mislabeled. This is mislabeled. This is not a 2000 watt. This thing could not do 2000 watts. The output board could. Output board could probably do about 4000 watts, or even a little more for a while. Most of the time an inverter this size would have TO220s in it instead of TO247s. Wee little transistor. Well, this would be a TO220. So there you go. So, parts wise, it's worth maybe trying to desolder these things out of here and use it for parts. It did have 4 good fuses. I put 4 of my own in it. What's going on? Maybe I'll see it now. See the crack. There's a crack in that FET, and there's a crack in this diode. This is actually a FET. They're just using it as a diode. You see here they actually broke off the one terminal. They're using it as a diode. It's possible maybe I could buy a pack of these FETs and I might be able to use the FET as the diode over here, so I'd be able to use them out of the same pack. But you know, given the fact that the input board and the output board on this thing is shorted or burned out, it's very possible that I could put all this money into it. Probably at least of $20. But like I said about getting these out of here, it's possible maybe I can get to these screws with some needle nose, and you know, get the, keep working back and forth getting these screws out to replace these. But at this point, it's just not. This thing ain't worth it. But so I would watch your back on buying the Peak 2000 watt, because this is not a 2000 watt inverter. There's no way. There's no way that the input board could do it. I might actually save this output board. I have to get in contact with the guy that this belongs to, because I could potentially use this whole board probably in my Harbor Freight 2000, 3000 watt inverter. My 2000 watt Harbor Freight has 6 of these. A little smaller guys in there, but well, I guess just call it a day for this video, even though it really wasn't very productive. And catch you guys later.